Again, hello everybody, and thank you for joining me for this session about Lumberjacking on AWS, how to do log analysis on AWS. My name is Guy-Ernest. I am part of the solution architecture team with a focus on big data, analytics, and machine learning. I got yesterday night in the restaurant, the Chinese restaurant, I got this fortune cookie. So in the future, you will be able to predict the future. I wanted to share with you because I think this is also relevant for you. Not just because you are here, and we were going to talk about how we can actually do that, but also because we see many of our customers are starting to do log analysis, how to crunch their log, their history log, and how to predict and increase their business success in the future. So in the past, it was quite hard to do log analysis. Only few companies were able to afford it. But if we look on those data points and these very significant hockey stick trends, you can see that things are changing. If we look, for example, on the storage cost, we can see that it's decreased quite dramatically from $14 million back in 1980 to less than $70 in 2010. If you check the CPU cost, that is one gigaflop of CPU back in the days was more than $1 billion, and now it's less than half a dollar. And the same with the number of hosts that are connected, that we can analyze those host data, and the bandwidth cost also is decreasing dramatically. But if we go deeper into the details of those numbers, we can see that the progress is not that even. That is, we see that the disks are becoming cheaper, they're becoming bigger, they're becoming faster, but it's not in the same speed. That the price can reduce by 450,000 since 1980. The standard disk size increased from 100 megabyte to 3 terabyte today. It's an increase of about 30,000, but the speed of the disk is not increasing that much, a factor of only 50 since 1980. So this leads us to the need of doing things a bit differently, using things in a parallel way. So if you want to actually enjoy the reduction in the cost and the increase in all the other parameters, we need to start thinking of using more spindles, using more parallel work. So more spindles is the way to go. It's the wrong spindle. I searched for spindles, and I got this picture. I shouldn't trust the search engine with my workload, but I think it gives the same meaning that we want to get, is that basically we want to use our low-cost worker to work in a parallel way on our data to make it run faster and more effective way, and we can get more and more worker and get more and more done in a parallel way. Let's start with one company that's already doing log analysis, and basically all their business is based on log analysis. This is Foursquare. I assume that most of you are familiar with this service. It's having 40 million people around the world. From the early days of mobile and online check-in until today, they are crunching more than 4.5 billion check-ins, and they are adding millions of check-ins every day to their crunching processes. And so this is the screenshot of my Foursquare page. When I entered yesterday night, I checked for the area of the conference, what we can do in Las Vegas. After we are finishing with all those fascinating technical sessions during the day, we want to have some fun in the evening time, and I searched for some art-related venues in the area, and I got this list very nicely, very good recommendation for what we can do after time. But what if we could check what's going on behind the scene, what's happening inside Foursquare where they need to analyze and create those recommendations and those analyses, we can see that the challenge that they are reporting was how can they stream hundreds and millions of application logs each day. And since the company is relying on analytics, the application itself is completely free, so they actually need to be able to do this daily reports on their infrastructure and for their customers, and they need to do it in a very efficient way. So AWS can give them the infrastructure, the tools to actually create this local analysis process in an affordable way, and we're going to talk about this today. So what we're going to do, we're basically going to build a system just like the one that Foursquare is having. So if you go around your organization and ask for, what do I need, what do you need from me? I'm going to build an analytic project. What kind of question can I answer you? And you go around your business unit, you will get different answers. So in the past, logs were only part of the operation. So basically, we checked for problems. Developers use the logs to debug their code. But now, we are beginning to start getting new requests. Our marketing team would like to optimize their marketing budget, and they have questions regarding this effectiveness. We can see that the CEO team is asking, how can we analyze our costs? How can we analyze our revenues? How can we actually build a more viable business? So as long as our business is growing and we're getting more and more users to use our service, we want to increase the ratio between the cost of each of the serving of each of our users and the revenues that we can generate from those users. So running those analyses, those metrics, can help us increase and create our viable business. So we got the list of metrics. Now we can go and check which logs in our system, what are the data sources we can use to actually answer those metrics. So we can see that we have a list of sources. CloudFront, the CDN service of Amazon, can give us many of those answers. Some of the data is hidden in the web server, application server. We can also join the data that we have in our order databases or our user databases. So we have a long list of data sources that we can basically use to build our project. So how is the right way to start? So first, we need to understand the data. What is the format of the files? And let's check this CloudFront format. So it's a nice format. It's a TSV file. We have a nice header. The header tells us that we have the date, the time, the edge location that it's serving each of the files, what was the size of each of the files that was served, what is the IP that requested. Quite a lot of data, very nicely organized, but it's not enough. We need to know a bit more. We want to know what values do we have in the columns. We want to know what is the cardinality, how many values we have. We want to know what is the distribution of those values. It's very important for us before we are starting to join the data and put them into other analysis tools. So I think that the very easy way to start is to start with R. R is a very powerful and popular tool among data scientists. So here you can see how I can, in a few lines of R code, load the data. I can remove the header. I can see the data in a table view. And then I can create a plot of one of the value of one of the columns. And in this case, I chose to check the status of the request. And you can see that most of, maybe it's tiny letters, but the majority of the status code are 200, of course. This is a log scale of the Y. This is why it doesn't look that big. And also we have 304, 404. So more or less we understand what kind of value we can expect in this field and what is the distribution of these values. But you should know that R is quite memory hungry. And instead of you trying to go to your IT people and ask them, I need to increase my memory in my machine, I think that you can also use one of my favorite tricks is to actually run in the cloud. So as you can see, this machine, this RStudio machine, I can launch whenever I need to do this kind of analysis. This machine has 64 gigabytes of data, unlimited for my use case. And whenever I finish my my analysis, my understanding of the data, I can delete the cluster and continue with my life. If writing R code is a bit complex for you, and you feel that you want to have something easier to do, you can also use OpenRefine. You can, again, run it on EC2 instance, and with a point and click, you can create a table view of your data. This is the same data that you saw before with R, and on the left side, you can see the facets that you can create on those values. And the same status code, you can see that the majority are 200 and so on. So it's easier maybe to do if you are not familiar with writing R code. OK, so now basically we understand our data. Of course, we did the same analysis to other columns, and we understand it much better. And we can start planning on actually creating our project. Usually, this kind of project are in this kind of a format. It's called the ETL, the extract. We are extracting our logs from the various sources. The T for transformation. We are transforming the logs. We are cleaning them. We are filtering them. We are enriching them. And then we can load them into our data warehouse. So this is our ETL process. And when we want to start doing that, we want to use AWS for that. And this is what we came up when we did the whiteboarding on the service. So the plan is as follows. We're going to extract the data from our edge location. We're going to run transformation using EMR, which is a very good tool to run transformation in scale. And we're going to load it into Redshift as the data warehouse. And we can also get some data from RDS. Remember the user tables or our order tables, and we can upload them into S3 and then to Redshift. So this is the plan. Let's start building our system. So here's our system. Here are our users. They are accessing our web servers. They are accessing our CDN network. And we want to get the logs from the many edge location of CloudFront. CloudFront is served from more than 40 edge locations, but we can get the data from all of them with just defining, enabling logging in the management console, as you can see here. So you are enabling the logging. You are defining to which bucket you want your logs to be sent. And basically, you have already all the logs ready for your processing. But if you want to have logs from your web servers, if you want to have logs from your application servers, basically you need to start doing what is called log shipping. So as you can see, log shipping is a hard work. It requires real men with very specific tools. But let's try to make it a bit easier. What is the easiest way to actually create log shipping for your servers? So this is a personal note that it's very enjoyable to be a solution architect. One of the most enjoyable things is basically meeting amazing customers. And this is a story of a customer that I met that when we talked about his analytic system, he told me that he has one. He already is doing log shipping. And he showed me this S3 bucket. When I look at it, I ask, where is the shipment? It's simply you have a small, tiny object and a log folder. How do you do it? Then he pointed me to the documentation. And if you look at the documentation of the server access log, you can see that the request URI is part of the log. So what you can do is just put in the URI all the data that you want, and S3 will ship all the logs for you without you needing to do anything else. And this is a way that you can embed your invisible pixel. This is what you call a poor man invisible pixel. So you're calling for your tiny object, and you're putting all the other values, the version, user ID, campaign ID, and you can implement that with this kind of a simple mechanism, no cost other than the cost of the storage of your S3 logs. So here's a system. We have our content delivery logs sent, we have the invisible pixel logs sent, but we might need to do something more than that. Not everything can be embedded into the invisible pixel. What we need to do now is basically to do log shipping with other framework. And for that, you can use a set of open source framework. I like specifically FluentD, especially for this retro ASCII diagram that they have that basically tells it all. That all you need to do is basically define your input. In this case, it could be your web server. Define the medium. In this case, it's FluentD, but it can be the others. And you define the output. In this case, S3. And you can gather your data from your web servers, from proxy servers, from database servers. And it's working very, very nicely. Again, FluentD is one option. Flume, Scribe, Chakwa, all of them are very powerful, very popular. FluentD has more than 100 different plugins. So basically, you can actually get your data from everywhere, and we can implement this architecture of log everything, which basically this is what we want for our project. Another option that was announced yesterday, you can use Amazon Kinesis. This streaming service is helping you to put all your logs from the many web servers, application server, wherever you have your code running, into the stream, and then write this Kinesis-enabled application that will take the logs from the stream and put it into S3. If you download the jar, the libraries that we put as part of the service, you can see a set of connectors already ready for you, and one of the connectors is for S3. So actually writing this kind of Kinesis application shouldn't be that much problem for you. OK, very good. We did quite nice progress. So what we managed to do is now we have all our logs from all our sources into one S3 bucket, and we can start doing our transformation. So done with the extraction phase. The first step in the transformation is basically use the S3 distributed copy. Why do we need to do that? So if you remember, we're talking about parallel processing. And parallel processing prefers to have large files to process, and it likes to have the files in an even size. That if you have one big file and few small files, what you will have is that one of your workers will work very, very hard for a very long time, while the others will be idle and wait for their work to come. So this kind of underutilized cluster is something that we want to avoid. Another important thing that you would like to have is to have the files compressed. That is, if you remember, the files that are coming from CloudFront or from S3 are already compressed. But the files that you are generating from other sources might not be compressed, and it's going to be a lot of waste for you. You will wait a long time for the files for the logs to move because they are bigger. You will pay more for the bandwidth. You'll pay more for the storage, and it's better to avoid it. And S3 distributed copy basically gives you all of that. It will aggregate the data for you for larger files. It will also make sure that the files are more or less the same size, not going to be accurate, but more or less the same size, and they will be compressed. And this is done by a single command. So this is an example of how you do distributed copy with EMR. So you are specifying what is the source bucket that you want to do. You're specifying this destination. What is the format of your aggregation? Basically, this is a date format. What is the target size? In this case, 128 megabyte. Of course, compress it with LZO. And also, at the end, whenever I finish copying a file to the new destination, I can delete it. Again, saving on our storage cost. So with this single command, we can basically get the files ready for our next step. So the files are sent into the EMR, the Elastic MapReduce, which as the first phase did our distributed copy. But now we can actually run a set of steps that will help us to make this transformation. The steps can be in Java, implementing the MapReduce interface, but it can also be in one of the high-level languages that are available for EMR, for example, Pig, Hive, streaming, cascading, and many of them that you can choose from. Let's see an example of a Pig script. This is a Pig script that actually analyzed the invisible pixel example that we saw in the beginning. I like to call Pig shell in scale. Why? Because whatever you can do with shell on a small file, now you can do in unlimited scale using Pig. Let's see an example. So the first stage of the script, we are basically loading the data and filtering, which is exactly like what you would get if you run a cat or a grep command. The second phase is to do this parsing. That is, what values do we have inside? You can see that we are getting the user ID, the campaign ID. And this is very similar to what you would write if you are writing awk command. And at the end, when we finish our processing, we just store the data back, very similar to what you can do with shell. So it's quite simple to write a Pig script. One note about the comparison between Pig and Hive, because many people are asking which language is better. So of course, it depends. So Pig is more geared into ETL stuff. I see more developers or more people who are used to, system administrators who are used to run shell using Pig, while the analysts, people who are more used to writing SQL, are using Hive more frequently. Hive has this HQL, which is quite similar to SQL, so it's very easy for them to pick up. But you don't need to decide, because when you are running your EMR, you can run various steps and in various languages. Pig makes it very easy to write MapReduce code. But when it's too easy, sometimes you're missing some of the optimization that you can get. And this is why I recommend also using this specific tool. I think it won one of the prizes yesterday, Netflix prize in Werner keynote. So Lipstick actually giving you an insight about what's going on underneath the hood of your Pig script. So you're running a Pig script, and you can see what are the map and reduce steps that are happening, and which one of them is taking longer, so you can actually optimize your Pig to run in a better way. There is another tool, Ambrose, that was open sourced by Twitter. Also giving you this kind of flow, how your job is going through the system, what takes longer, what is stuck, and this kind of insight into what's happening underneath will give you a better understanding about how you can optimize and make your EMR jobs run faster. Actually, how we like saying it, that the Pig will fly, which it can. Another thing that I think that it's important for you to know is that you should optimize your EMR cluster. And this is an exercise that one of my teammates did a few weeks back. What he did is he took a spreadsheet. He put all the instances that can run in EMR. He put the price of the hourly price for each of the machines. And then he defined a budget. The budget was $10, $10 an hour. How many machines can I have in $10 an hour? For example, if I choose M2 extra large, I can have 21 machines. So it's different layout, bigger machine and fewer of them, or smaller machine and more of them. Then he calculated the accumulated CPU, memory, and storage that he can get from each one of those layers. Then he added another dimension, which is the network. He estimated how much network he can get to the disk, how much network he can get in the cluster between the nodes, and how much network he can get to S3. Again, these are estimations. You can calculate it. Then he, of course, made the colors. Which one is better? It gives you a very easy way to understand that your layout will define what kind of workload you can run with that. So if you need more CPU, maybe it's better to have the C1 extra large. If you need more memory, it's better to run with the M2 extra large. If you need more network, we have the M1 large. So in our case, when we analyzed when we estimate or evaluate what we think will be the bottleneck, we estimate because we are doing distributed copy, which is basically copying the file from S3, and we are running pig, which is quite simple, doesn't require too much CPU and too much memory, we will be network bound. So this is kind of a theoretical exercise that we can do to try to estimate what is the best way to lay out our cluster to maximize our performance. But you don't have to rely on theory. You can also try it in a practical way. So you can monitor your cluster. This is monitoring using Ganglia. You can see that you can check the CPU of your instance. You can check the memory of your cluster. You can check the network of your cluster. And again, it's showing us that the bottleneck of this specific process that we are running is network, and we can optimize it to define the right layout of our system. It's quite easy to install Ganglia. This is a single bootstrap action that you put as part of your EMR launch. Or you can also use it from the management console. When you are starting a console, you can define that you want Ganglia to be added to the cluster, and then you can log to the server and check your metrics. If this management console looks a bit different than what you are used to, it's because it's recently updated. Last week it was updated to this view, so now you can have these options already. It's also gathering the relevant CloudWatch metrics from around the system into the EMR console, so you can actually see from here also the bottlenecks or the usage of your cluster, the same network, memory, and other resources that you're using. And you can also see the steps, the failures. Most of the resources that you now need for EMR are available through the management console in an easy way. Another tool, which I like, is something that was recently open sourced by Hive Media. This is another clever implementation of how can I get more data, more understanding about what's going on in my cluster. So what they actually did, they are querying all the APIs, the EC2 API, the S3 API, of course the EMR API. They are checking the job tracker from the Hadoop. They are also asking for the EMR pricing from the site. They are gathering all this information and creating this textual console and this even visualization that can help you understand what's going on. This is an example of how a complete job can look like. So you have a lot of data to dive into and get a better understanding about what you can do better in your system. So what we managed to do is we gather the logs into S3. We already make most of the transformation with EMR. We try to optimize as much as we could our cost. But one of the most powerful way of lowering the cost of our processing is using spot instances. So I guess that most of you already know about spot instances. Hopefully, most of you are already using that. So I am not going to teach you what is spot instances. But what I can do is basically I can share with you some strategies that I see our customer actually doing when they are running spot instances. So this is the market price, the on-demand price, for this C1 extra large. About 64 cents. So one strategy is most saving. I will pay 20%, 30%, not more than that. So if it's more than that, I don't want to run my job. I will wait until the price will go down. And the price can go down, and it's usually around the 10% of the on-demand. It's a huge saving. So if I want to do more saving, I will bid very low. Some of them are saying, I want to not pay more the on-demand. So they are bidding 80%, 90% of the on-demand price, and then they're getting more time of off-spot, and they're still paying less they will pay with running the on-demand prices. But we also find some customers that are using more than the on-demand. They can ask for 150% or even 200% of the on-demand price. Why do they do that? And of course, I explained them, you're going to pay more with spot than you're going to pay with on-demand. It doesn't make sense. So they said, yes, it makes a lot of sense for me, because then I get less interruptions. I can run my jobs faster. I will get more time. And even if for 1 hour, 2 hours doing my 2 days of job, I will pay a bit more than the on-demand. Overall, I will save a lot, because overall it will be 60, 70% of the on-demand on the whole time of running the job, and my job will run faster, I will get less interruption. So it's really up to you to decide what is the risk that you want to put on losing your instances, and use that to define what is your bidding strategy. But I don't encourage you to put more than the on-demand, but basically there are customers who are doing that, and they are still saving a lot of money. So I want to take you back to the early days of Amazon.com. So this diagram was drawn by Jeff Bezos himself. I don't know if it was a napkin, but it's a good story. So he drew that to explain how Amazon.com can continue growing. So it all starts with the customer experience. What customers are looking for is have selection. I want to find what I want to buy, and they want lower costs. Once we have that, we are generating traffic, people are coming, people are buying. This attracts sellers. When the sellers are coming, we have more selection. And when we are selling more, we can also invest in lowering the cost of our structure and reducing the cost once again. And this creates the flywheel. This is how we can start growing and growing and growing, because this is a very powerful flywheel of customers coming in, sellers coming in, more selection, lower cost, and the business is growing. And this is how Amazon.com is growing until today. Let's try to use the same mechanism to grow our business analysis project, which we started. So what we want to actually get is more data sources. These are the sellers. We want to have more queries answered. Once we have the ability to serve more queries, again, we'll have more customers. This time the customers are internal users, or maybe can also get external people to buy our reports, but still customers. And we can start growing, again, this flywheel of our agile data warehouse project. What we now need is basically this kind of a lower cost structure and enter Amazon Redshift. But before we're going to jump into Redshift, the question can be, why use Redshift? Why not use regular databases? There are other databases out there, and Redshift might not be the best solution. So for that, I think that we should consider the following trends. So basically, when we are moving from the transactional processing to analytical one, what we see that the context has changed from transactional to global. The focus from latency of each transaction, we are talking about throughput. How many records could we process in a second? We are not using indexes anymore because we are doing a full table scan. We are not doing random I/O, we are doing sequential one. And we want to optimize our disk not for seek time, but for a transfer. So basically what we actually need is a different hardware, different type of database, and this is why Redshift is running on this kind of optimized hardware for analytics. So let's go back to our system. We did all the analysis, all the transformation, and now it's time to load it into Redshift, the L in the ETL. How do you do that? Basically, it's a single command. So the first command is to create the table. This is the create table that is loading the data from the original files from CloudFront, sorry. And with a single copy command, I'm taking the bucket that I put the output of my CloudFront. I'm giving the credential of my S3 bucket, so Redshift can read the data from there. I'm ignoring the header. You remember I had 2 lines of header in the log. Of course, the data is gzip, so it's important to put it in the command, and putting the date format. So after this command, all the log files, and I'm talking about this kind of parallel loading. So if I have thousands of files in S3, they will be loaded into Redshift in a parallel way, in a very fast way. So it's compressed and run in parallel. One note about optimizing Redshift. Of course, there's a full session about how to make your Redshift run faster, but a note that you can see in this slide is that it's important to decide what is the format of your columns. So don't load everything as string, which might be a temptation because it's the simplest way. If you load date as date, numbers, and so on, you will get much better compression, which will make your Redshift queries run much, much faster. If you want to schedule and create this kind of automatic way of loading every hour, every day your files, AWS Data Pipeline is there, and this is an example of how you can define loading your data. You can see that the top one is taking the data from S3 bucket in an hourly upload into Redshift, and then the second one, the bottom one, is taking your data from your databases on a daily basis. I want to do it on a daily basis because I don't want to add load to my production server. So once a day, it's enough for me to get the transaction there. So using this kind of pipeline will give me the data fresh all the time into my database, into my data warehouse in a very scheduled and automatic way. So we've got our data in the database, in the data warehouse. Now it's time to make some knowledge, to tell a story. So time for data visualization. So I'm not sure that you can create this kind of visualization in Redshift. This is a very famous visualization from 150 years ago. What you can see here is this brown line. This is the army of Napoleon leaving France on its way to Moscow on the top right side. And you can clearly see the path that they took and the decrease of their size as they are fighting their way to Moscow. And then you can see their retreat, the black line going from Moscow back, and the few that managed to start even their journey back to France, and the even fewer that got it all the way back to France. It's a very powerful story, a terrible one, but it's a very powerful story that if you try to make it in table and numbers, it will be very, very complex, but one single image can give you and tell you this story. So what we want to do is actually tell the story of our data, tell the story for our customers. So what kind of story can we tell with the data that we loaded? So this is some kind of a dashboard that I created on the CloudFront logs. So you can see the increase of number of users coming to the system. It's a success of our marketing launch. You can see the distribution of the ages and the gender of our users, because this is a gaming site, so it's not a surprise that most of our users are the age of 15 to 25. Two-thirds of them are male. It's not a surprise that this is a distribution. And also we can see the top 25 games and which countries are downloading and buying which game. It's very, very important for our business to start seeing the data as it is. So how do you do that? Basically, you can choose your own favorite BI tool. So there are many of them. In this case, I used Tableau on a Windows instance. My shop is a Linux shop, but if I need to run some BI tools that are only Windows-based, like Tableau and Sense and ClickView, which are very powerful and popular, I can start them on a Windows instance, run my dashboard, and use that to publish to my internal and external customers. There are also solutions that are more open, like Jaspersoft and MicroStrategy, that are also running on Linux machine. But there are many of them, and I can't even put all of them on one slide. You can check them in the AWS Marketplace. Another option, if you remember, this R machine, R in the cloud that I had in the beginning to analyze my code. I can also use that to create some more interesting or powerful visualization, and this is a visualization that I created, which basically trying to show which games are downloaded with other games. So this is a kind of a heat map. I've got the game on one side, the same game on the other, and you see which games are working nicely together. So one of the most popular game is Netrec, which is downloaded quite often, and the most common game that usually goes with it is this game, which Tile World. So having this kind of understanding and this kind of information can just be the first step into my recommendation engine. I can use that to create my site differently, to allow this people who bought that also bought this, and so on. So this kind of a very powerful way of getting the data to work for me to generate more revenues and getting more people to download more of my games. So we did a lot of work. In this less than an hour, we managed to gather the logs, process them, transform them, load them into Redshift, and even create our visualization. An important thing that I wanted to remind you that Redshift is very low cost, but it's even lower cost when it's not running. What do I mean by that? It is basically what you can do is you can snapshot your Redshift and you can delete it when you would like to do such a thing. Let's say that you're running your reports every month, and it takes you 2 days to run your reports. But why do you need the cluster to be up and running the other 28 days? It doesn't make sense. So what you can do is basically delete the cluster, of course, snapshot your cluster before you are deleted it. So next month, you can start your cluster from this same specific snapshot, and then you can load all the data that you gather during the last month and repeat your log generation and kill it again, and you can continue like that again and again. And you don't have to kill your cluster. You can also just unload data that you don't use. If most of your queries are running on the last week, for example, why do you need to have this history already all the time in Redshift when you only need it once a quarter, once a year when you're generating your yearly reports? So this is a simple way of unload your data, and then you can reload it once you want to run this monthly, quarterly, or yearly report, and then you can also resize your cluster to hold more of the data. So be very conscious about the size of a cluster, the amount of data that you have there, so your project will be cost-effective for you. So what we build here is the reference architecture. I believe that it makes sense how it's built, why we build it, but you might use it differently. Maybe you don't need EMR, maybe you have another ETL tools that you want to use, maybe even you want to use a different data warehouse. Everything is possible, but I think that it makes sense why it looks like that. If what we build here is a bit too complex and you want maybe to do it even easier, you can use many of our third-party tools like Logly that you can find in the AWS Marketplace that will help you generate and understand and go cut through your logs. Splunk is another powerful one. Logstash is also a powerful tool. So using those can give you maybe even the taste, should you move forward and should you build your own log analysis tool. So now we are very good about log analysis. We know how to build system. We know how to optimize it. We are doing a very, very good job. What else can we do with log analysis? So once we are mastering this technique, this framework, what we can do is, for example, do A/B testing. So A/B testing gives you the ability to stop guessing. Currently, when you want to have a new version, you have a new pricing model, a new layout of your homepage, this kind of decision can be run in parallel. So you can run one version when your application costs $3 and one that when it costs less. And you can see how many clicks you can generate in each one of those models. So running A/B testing is quite simple once we know how to do this log analysis, because all we need to do is just run 2 versions, get the logs, which we already did, and analyze it again, which we already did. So this kind of powerful tools that now are for your disposal is something that you should consider, and it's going to be a good incentive for you to even start doing this journey into log analysis. But as you know, with the great powers come great responsibility, and it's very, very easy to make mistakes. When you have a lot of data, when you're trying to build your system, when you're trying to define this crucial business decision, you might get it wrong. And the story here is about Abraham Wald. He was a mathematician, a statistician from the Second World War. He worked with the Air Force. And what he did basically was log analysis. What is log analysis for him? He measured where already defined bullet holes in the planes that returned from missions to occupied Europe. So we draw this kind of very interesting visualization of the planes and the place we're going to hit. And now we need to decide where to put extra armor. Of course, you can't put extra armor everywhere, because then you might get heavy planes, slower planes. You need to find what is the best place to do it. So where would you put your armor? Was it going to be A, where you have the hit in the wings? Going to be B, or maybe it's going to be C? So it's not an easy decision. If you think of for a minute, you might come to the wrong conclusion, because where he decided to put the extra armor is here. Why did he do that? Because basically what he measured was the plane that did return from mission to Europe, and not the plane that did not. So the planes that got hit in the other places simply couldn't make it home. So why it's relevant for you? Because remember that what you are measuring is basically the people that did come to your site, that did buy the data, did buy your games. And if you are taking the wrong conclusion from this kind of data, you might miss the point. And it's very important for you to remember that remember what you are measuring. Remember what kind of conclusion you can draw from that. So this is a very, very interesting project we managed to build. We managed to gather our logs. We managed to transform them. We managed to load them into our analysis. And it was, I believe, quite simple. I hope that when you look at that and you are trying to go back home and try to implement what we talked here, I think it will give you, in a couple of days, hopefully, in this agile and iterative way, the tools to create the flywheel that we discussed, the business that you can start pushing inside the organization and make your company more data-driven and create new revenue opportunities for you as a business. And I also hope that I managed to get you interested a bit more about architecture. So here are some interesting URLs that you can find more architecture information, technical articles, and the blog that giving a lot of hands-on experience with our services. And also we have a few reInvent sessions that you should check. Most of them maybe are over, and you can check them on YouTube later on, but they're also relevant for what we talked here. So again, thank you very much for your attention, and I'll be happy to take more of your questions down on the stage.